Question number 8. We've got some ethanoic acid reacting with some magnesium. An acid with a reactive metal like magnesium is going to make hydrogen, and we've got a graph showing the hydrogen being made. With the aid of calculations, show that the magnesium is in excess in this reaction. So let's have a look what data we're given about the magnesium. We're given 395 milligrams of magnesium, and we know magnesium, Mg, has got a mass number of 24. So we've got its Mr, 24, we've got 395 milligrams. We can convert that into grams. So if we go smaller into larger, we divide by 1,000, that's 0.395 grams of magnesium. Moles is mass in grams, 0.395, divided by the Mr, moles over Mr, over 24. So your first thing to do is 0.396, should be 395, 0.395 divided by 24.3, which is the accurate Mr of magnesium from the periodic table, equals 0.163. Now your next thing to note is you've got a volume. You've got 30 centimeter cubed of 0.6 mole dm to the minus 3 ethanoic acid. You've got a volume and a concentration. So concentration equals moles divided by volume. Concentration is moles divided by volume, so moles is concentration multiplied by volume. This volume, centimeter cubed, is going to be in decimeter cubed, so smaller into larger I'm dividing by 1,000, that's 0.03 decimeter cubed. So I'll multiply those two together and I end up with 0.018 moles of ethanoic acid. Now when you actually look in this equation, 2 moles of ethanoic acid only react with 1 mole of magnesium. So if I've got 0.018 moles of ethanoic acid, it will react, 2 moles react with 1, so it will react with half of that. So 0.018, 2 reacts with 1, 0.018 would react with 0.009, half of that. So I'm going to need 0.009 moles of magnesium to react with the ethanoic acid, and I've got 0.163. I've got more than I need. If I subtract these two numbers, it will actually tell me that I've got 0.0073 moles of magnesium in excess. What's my next thing here? So I've got 20 centimeter cubed of 0.8 moles decimeter cubed of ethanoic acid. I've got a new volume and concentration of ethanoic acid. Why on earth would they give me volume and concentration? Again, concentration is moles divided by volume, so moles is concentration multiplied by volume. The only reason they give me volume and concentration is if they wanted me to work out moles. 20 centimeter cubed, small units into a larger unit, a decimeter cubed that we need for this equation, divide by 1,000, so 0.02 multiplied by 0.8. is 0.016. I've got 0.016 moles of ethanoic acid this time. They must have wanted me to work that out, otherwise they wouldn't give me a volume and a concentration. So I've got 0.016 moles of ethanoic acid this time. Previously I had 0.018 moles, so I've got 0.016 rather than 0.018. So I've got slightly less, so I'm going to get less product. Let's have a look at my graph here. 0.018. 0.018 is the number of moles of ethanoic acid that I have. This time I've got 0.016. So proportionately, 0.018, if these went up in 0.02s, 0.02, 0.004, 0.06, 0.08, 0.01, 12, 14, 16, 0.018. So 0.016 would go up to this graduation here. So 0.018 goes up to here if I go up in 0.02s, and if I'm going up in 0.02s, 0.016 goes to here. So my graph will go to here, up to this line, and it's going to go more shallowly. The reason it's going to go more shallowly but through the origin is that it's going to go steeper because it's a higher concentration than before. It's 0.08, whereas before it was only 0.06. So it's going to go steeper because it's a higher concentration, so you've got more particles within the flask. You've got close particles are closer together, more successful collisions. So particles closer together in my newer higher concentration, it's going to go steeper, but only up to that line there, 0.016, because I've got less moles, because I've got less volume.